This video is on the skill area involving inscribed figures. Inscribed basically means that one shape is tucked snugly inside the other. As you can see here, we're looking at a rectangle and a circle inside of it. Okay, so the circle is snugly inside the rectangle, or the square in this case. You can see that the circle literally hits the sides of the rectangle or the square. Okay, so we're going to find the area. It says a circle is placed in a square. Okay, so we're dealing with a square and a circle. And the square has a side length of 16 yards. You see that represented below. It says find the area of the shaded region, this dotted area, which ends up being in 4 little parts. It says use the value of 3.14 for pi with your circles, and do not round your answer. Be sure to include the correct unit in your answer as well. So we need to make sure we have our label at the end. Okay. For area involving inscribed figures, we're going to use a shapes plan. In order to find the dotted area, the large shape is the square. So we're going to take square, and we're going to cut out of it the circle. Okay, so if we find the area of the entire square, think of it like a paper. The entire square, find its area, and then we're going to take our scissors and we're going to cut out that big circle. Okay, so we're going to find the area of the circle. If we have the rectangle or the square and we subtract out the circle, what remains of the paper are just those little sections here, the dotted sections. Okay, so this is our shapes plan, square minus circle. And over here to the side, I gave you the formulas we're going to use. For a square is base times height, and for a circle is pi radius squared. So coming down here, base times height. The base of the square is the same as the height of the square. So we have 16 times 16. We'll go ahead and do that. If you have a calculator handy, go ahead and use that. If you don't have it, go ahead and pause the video here and then go get that. 16 times 16 is 256. Okay, so that's the area of the square. Now we're going to find the area of the circle, which is pi radius squared. They told us to use 3.14 for pi. And we have to square the radius. Now, the radius of the circle, that is interesting here. So, the height of the square is 16 yards. The height of this side is also 16. So we can conclude that the distance straight down through the square is also 16. Okay? The distance straight through the center of a circle is the diameter. Okay? So the diameter of our circle is 16. Our formula, though, calls for the radius. Okay? So if the diameter is 16, there are 2 radius in every diameter. So the diameter is just half of the 16, which is 8. Okay? So our radius in this picture is 8 yards. Okay? If I went too fast, rewind it, listen to that part again. Okay? It's important that you understand how to find the radius from that diagram. Okay? Radius is 8, and we're going to square it because of the formula. So 3.14 times 8 squared. Squaring wins out over multiplication. So 8 squared is 64, and then times the 3.14. So in your calculator, 3.14 times 64 is 296 hundredths. That's our area of the circle. And then we're going to subtract those 2. That will give us the area of the dotted part, or the shaded region. So 256 minus the 296 hundredths is 55 and 4 hundredths. Okay, it doesn't want us to round, so that's our answer, 55.04. And our label is yards squared. Okay, yards squared because we're talking about area. Our second example has a rectangle placed around a semicircle as shown below, and the length of the rectangle is 14 millimeters. Find the area of the shaded region, use the value 3.14 for pi, and don't round your answer. Be sure to include the correct unit in your answer. So our shapes plan this time is going to be rectangle minus a half circle or a semicircle. Okay. Our formula for rectangle is just as it was for the square, base times height. All right. So area of the rectangle. Now I've given you the area of a circle, which is on your formula sheet as well, but we don't want a full circle, we only want a half circle. So we want to take that formula and divide by 2. Okay? So our formula for a semicircle looks kind of involved. Pi r squared, and then that divided by 2. Okay? You can do it. So starting off with a rectangle, our base is 14 down here because this is the same as this. And then our height, we have to decide what is our height. Okay? Now, our circle here is only half circle, but you could imagine that the rest of the circle kind of comes out here like this. Okay? This here then represents the diameter of the circle. Okay? Being 14. Right? That also means that going this direction is also the diameter of the circle, being 14. So if this is truly a half of the circle, our height here will be the radius of the circle. Okay? If the diameter of the circle is 14, then the radius is 7. So from the top of the rectangle to the bottom of the rectangle is 7 millimeters. Okay? So our height is 7. Again, if you need to hear that again, rewind it just a little bit and listen through that again. Using your calculator, 14 times 7 is 98. And now we're going to tackle the area of that semicircle. Okay? Pi, we're using 3.14 as they requested. Radius of the circle, we already found, is 7. And we're squaring that. And then that entire thing is going to be divided by 2. Okay? So we have multiplication, we have exponents, and we have division. Exponents is going to win out over multiplication and division. So 7 squared, 7 times 7 is 49. We're going to take that times the 3.14 and then divide by 2. Okay? So 49 times 3.14 and then divide by 2. We get 76 and 93 hundredths. Okay, so area of the rectangle, 98. Area of the half circle, 76.93. And then back to our shapes plan, we're going to subtract those two. So 98 minus 76.93 gives us 21 and 7 hundredths. Okay, and they also ask for a label. We're still working with area, so this time our label is millimeters squared. Okay, and one last problem. This time we have a triangle inside a half circle or a semicircle. Okay, it gave us the radius of 6 feet. So for this shapes plan, we're going to be doing the big shape, which is our half circle, subtract out the smaller circle, or sorry, the smaller shape, which is the triangle. Okay, so again, this is our formula for a full circle, so we'll have to divide that by 2 for the semicircle. Okay, so formula, pi r squared divided by 2, and we're subtracting out the triangle, which is 1/2 base times height, or some of you like to use base times height divided by 2, which is the same thing. Okay, and you're going to plug your numbers in. So our radius is 3, given to us this time, which is nice. So we have 3.14 for pi. We're plugging a 3 in for the radius, and all of that divided by 2. 3 squared first is 9, and then 9 times 3.14 is 28.26, and then we're dividing that by 2. We get 14 and 1300ths. Okay, so area of the semicircle, 14 and 1300ths. And then we're going to find the area of the triangle. Excuse me. The base of the triangle and the height of the triangle are things we need. Okay, so we know the height of the triangle is 3. The height and base of any shape always run perpendicular to each other. So that right angle shows me that this is the base. Okay, if the height of the triangle is 3, how much is the base? Okay, that goes back to this semicircle again. Looking at this semicircle, if this distance is 3 feet, okay, think about it like a full circle. If this part is 3 feet, the radius of the circle, then this part here is 3 feet as well, the other side of the circle's radius. So straight through the entire circle is 6 feet. 3 plus 3 is 6. Okay, so the diameter of the full circle is 6, and then going this way, the base of the triangle is actually the diameter of the circle as well. So the base of the triangle is 6 feet. Okay, 6 feet. So in our formula, half times the base of 6 and the height of 3. Okay, you can multiply in any order, but I think this will work just fine to go from left to right. Half of 6 is 3, and then 3 times 3 is 9. Okay, so we're taking the area of the semicircle and subtracting out the triangle. So 14.13 minus the whole number 9 is 5 and 1300ths. And our label this time, still area, will be feet squared. Label is always squared for area. I hope this helps you with your skill. If you have any additional questions, please ask your teacher and make sure you have your notes out so you can refer to those. Thank you.